Hello Geometry, Miss Collins here, and today we're going to be going over section 1-5 and it's called pairs of angles. So hopefully you'll be able to describe what these are, and then based off of properties of these different types of angles, you'll be able to solve for missing values and angle measurements. So we have quite a bit of vocabulary. Once we get through the vocabulary, we'll be able to kind of talk about some more examples. But vertical angles is our first one. Vertical angles are angles that are opposite of each other. When two lines intersect. So what that looks like, let's say we have these two lines and we have angle 1 and angle 2. These two guys are vertical angles because they're opposite from one another. If we had, say, angle 7 and angle 8, angle 7 is opposite from angle 8, so they are vertical angles as well. Next, we have something called adjacent angles, and these are two angles that share a common edge. So that would look like this. Let's say that we have points A, R, and C, and point B here. So angle ARB is adjacent to, so I'm just going to put an and sign in there, to BRC. Oops, angle BRC. Now, if you had something else in there, kind of separating the angles out, say like this, let's say have A, H, and D, and then if we said, say, angle 1 and angle 2, here and here, 1 and 2 are not adjacent angles because we have this space right here. But we could say that AHB and BHD are adjacent because that's including the whole angle. So you just have to look at your image and determine if they have that shared ray in the middle of them to know if they're adjacent or not. You've heard of the word complementary before. It's when the measures of two angles add to 90 degrees. Now, they can be beside each other or they could be separate. So it might look like this. And we have, I don't know, angle 3 and angle 4. Or you might have two angles. Say this one's 30 degrees and this one's over here at 60 degrees. It's okay that they're not touching each other because they are still complementary of each other, because 30 plus 60 still adds up to 90 degrees. Supplementary angles, on the other hand, is when the measures of two angles add to 180 degrees. Now, sometimes people get these two mixed up. where they kind of know what they mean, but they might say supplementary when they mean complementary. An easy way to remember it is complementary starts with a C and supplementary starts with an S, and C comes before S in the alphabet, just like 90 comes before 180 when we're counting. So if you're one of those people that gets them mixed up, just think it goes in order alphabetically as well as their values. So supplementary angles add up to 180 degrees. Once again, they might be touching or they might not be touching. So let's say this one was 140 degrees and this one is 40 degrees. So we have 140 plus 40 getting us 180. Finally, we have something called a linear pair, and notice it has the word line in it. Line. So you guessed it, it's going to form a line. It's a linear pair. So what it's going to look like is two angles right next to each other, but they form a line. So they have to be both adjacent and supplementary. So two angles that are adjacent and supplementary. So this one might be 145 degrees and this one might be 35 degrees. And there's lots of examples that you can have for this as well. So now these are all of our vocabulary that we're going to be using for today. Let's kind of practice with that a little bit. In this first example, it says, tell whether the angles are only adjacent, adjacent and form a linear pair, or not adjacent. So in this first one, we have angle AEB, which is AEB, so this part right here, and BED, BED. Well, notice that AEB and BED, they both share this ray EB. So that means that they are adjacent. Also, when you put them together, they form this bottom line AD, so they are also a linear pair. Next, we have AEB and BEC. So once again, from A to E to B, this angle right here. And then BEC, B to E to C. Well, they share this ray EB once again. So because they have that common side, then they are adjacent. However, their values aren't long enough to form an entire 180 degree line, so we can only leave it with adjacent. Finally, we have DEC and AEB. I'll highlight this one for you so you can see them. So we have DEC, so from D to E to C, and then from A to E to B. Okay. Now, it looks, because of their bottom lines, that would be a linear pair. However, it's only this section and this section, and we're missing this whole big center part of the angle, so it does not form a linear pair. In addition, they don't share a common center ray, so this is neither. Or not adjacent, whatever. Okay. Looking at these examples on the back, it says find the measure of the following. We're trying to find the complement of angle F. Well, here's angle F and it's 59 degrees. The complement is the angle that will get it to 90 degrees. So remember, complementary angles add to 90 degrees. So what do we have to add to 59 to get to 90? We can just do 90 degrees minus 59 degrees, and that's going to get us 31 degrees. And that's our solution. The complement, or the degree that will add to 90 degrees with this one is 31 degrees. So here we have the supplement of G. We know that we need this angle to add with another angle to get us to 180. So we're going to say 180 degrees, just like up here how we took 90 minus we took 90 minus whatever was in the angle. We're going to do 180 minus whatever is in the angle. So 180 minus 7x plus 10. We can't find an actual value in this because we're not given enough information, but we can simplify it a little bit because these are degrees. So we can take 180 minus 10, which is 170. And this is just a little bit more simplified of an answer. But we have to leave it as this because we are not given enough information to figure out what x is or anything like that. So I'll go ahead and label supplement as 180 degrees one more time as well. All right, so for these types of problems, once again, you're just asking yourself, what degree do I need to get me to the desired number? All right, moving on, it says, an angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the complement. This is a little wordy, but here's how I'm going to break it down. I know I have 2 angles and they're complementary of each other, meaning they add to 90 degrees. So I'm just going to call them angles x and y, and I'm going to say x plus y is equal to 90. I know that much so far. Now I'm going to choose whichever one, it really doesn't matter. Which one of these do I want to represent to be the complement or the angle that this is talking about? I'm going to swap the y out. So the y is going to represent the word problem, is basically what I'm going to make it do. So this says that y is 10 degrees more than 3 times its complement. Well, the complement of y is x. So I'm going to carry down my x one more time, and I'm going to put y in terms of x, or the complement. So one more time, it's an angle 10 degrees more than 3 times its complement. Well, let's take care of the 3 times its complement first. This is going to be 3x. It is also 10 degrees more than that, so 3x plus 10 is equal to 90. Now I only have one variable, x, and I'm able to solve for this. So I have x plus 3x, which is 4x, carry down my 10. I'm going to subtract 10 from both sides. I need to move my work up here. So now I have 4x is equal to 80. Divide by 4 on both sides, x is equal to 20. So this one's challenging because you're trying to think of complement and then its other angle, but they're both technically complements of each other. So I did have to read through it more than once to kind of break this down, but if you need help on your homework with problems like this, then I will be around the classroom to help you out, because that one is a little bit tough to kind of make sense of. But anywho, we are almost done. In example 4, it says, light passing through a fiber optic cable reflects off the walls of the cable in such a way that angle 1 is congruent to angle 2. Okay, so I'm going to circle this and remind you that that symbol means congruent. And this is a huge vocabulary word. So if you can't remember what congruent is, write it down again, because this is not going away. Congruent is used just about in every single chapter in geometry. Congruent means same size or length, basically. Okay, so angle 1 is congruent to angle 2. So we have that marked in the image for us. And angle 1 and 3 are complementary of each other. So 1 and 3 form a right angle. So I'm going to draw that in. And angle 2 and angle 4 are complementary of each other. So that means these two form a right angle as well. If the measure of angle 1 is 47 degrees, I'm going to draw that in. Find the measures of angle 2, angle 3, and angle 4. So I'm going to go ahead and get all of that written out. Okay, and now I need to use what I know from my word problem and the picture. So it told me that angle 1 and angle 2 are congruent. And remember, that means same size or same length. So if 1 is 47 degrees and 1 and 2 are congruent, then that means angle 2 is also 47 degrees. Next, I have the measure of angle 3. Well, in this image, it's telling me that 1 and 3 are complementary of each other, meaning they add to 90 degrees. So I can say 90 minus 47 is going to get me 43. So I'm going to put that in for angle 3. And I'm going to put these in the image as well. Now, if angle 2 and angle 4 also add up to 90 degrees, it's basically the same problem as down here with angle 1 and angle 3. So I can use my same number that I calculated down here to fill in my angle 4. They end up being the same because I have two sets of complementary pairs of angles, and two of those angles are congruent to each other, so I'm kind of limited with my options on this one. Our last example says name the pairs of vertical angles. So I'm just going to kind of mark for you one pair. Remember, vertical angles are opposite from each other when lines intersect. I cannot just say angle M though, because that's too ambiguous. Does angle M mean this one or that one or the bottom one? So I have to use 3 points to name my angle, and remember the vertex is always in the middle. So angle HMJ and angle LMK. We do have another pair of vertical angles though, and they are on the left and right sides. So this guy and that guy. So I'm going to call that one HML. And angle JMK. That's it for our notes with angle pairs. We're going to spend a day of Math Excel and then another practice day with this because these are really important vocabulary words, and we'll be able to use these things throughout multiple chapters in geometry. So I just want to make sure that you have a good grasp of it. But until then, if you have questions, I'll be able to answer them tomorrow in class. Bye.